Welcome back to another edition of our MLOps Coffee Session podcast. Today, we are joined by none other than Sahbi, and I brought him on this show because I wanted to talk about the article that he wrote some time ago now, and it's all about machine learning systems and security of these machine learning systems. For those of you that have been listening for a while, you know that security is something high on my list of priorities when it comes to machine learning and that and a few other things. But we are getting into security specifically today. I will tell you that if you are not in our security and privacy channel on the MLOps community Slack and you enjoy these kind of topics, I guess that is the first important piece. If you enjoy or think that they are important, then jump into that channel because there are smart people sharing all that they can about security and privacy. And one of the great pieces that has been shared in there is the article from Sahbi. So with me as always is Vishnu. Welcome, Sahbi. And I'm excited to talk to you about this. Maybe we can start just by getting a bit of background information about yourself.
Yes, thanks a lot, Dimitrios and Vishnu, for having me here. Want to thank you also for all the work that you're doing with the MLOps community. It's really a community that I love. There is so much content, good content out there. A lot of experts sharing really interesting things. A lot of subjects that we talk about in the community. And you always bringing superstars in your meetups, and so thanks a lot for all of your work. So to present myself, I'm Sahbi. I'm a data scientist. I started working like 6 years ago in a startup in Paris. So we were actually a bit early, so we started trying to automate machine learning and also work on putting models in production and explain these models 6 years ago. And after that, now I'm working at SAS. So it's a much bigger company and with a lot of powerful tools also to manage this data science world in order to have the best platform for data scientists.
Awesome. So I think the logical question here is, why did you write this paper? What inspired you to write the article?
Let me start with a story all data scientists experience this kind of things. It's what I call now you put it into production kind of situation. So it's not directly related to security, but it happened in my early days as a data scientist. I worked on a huge project, so it was with an international customer. We spent a lot of time on this project, working with the customers. We went abroad. It was in China. The customers came to France to work with us, and we did a really good job to actually have the best model in terms of performance. And once this work was finished, you have my boss who came to me and you said, great, now you put it into production. And that's where you start to think about all the things that maybe you could have done differently if you want to put your model into production. Maybe you used some data that you want to query in real time, but your model would be offline. So this doesn't work. You made a super complex architectures of models, ensembling different models, and it's too difficult also to deploy it. So there are a lot of choices that you make when you're building your models, choices that you do differently if you had the visibility about what are you going to do and what are you going to put in production. And I think that security is one of these choices that you could do differently if you're aware of the implication of what you do. So recently, I started to think, as a data scientist, of course, I want to have the best performance for my models. So most of the time, I'm going to fetch a lot of data in order to have more data from different parts. It can be, for example, scrapping some websites using some open data, going and using a pre-trained model from GitHub. And actually, when you think about that, each one of these choices is actually a security threat. It's as soon as you go and fetch something from the internet, so some external data or models, there is a risk so that this kind of data could be malicious or could contain actually something that is a threat for the security of the model. So that's how I started to think about the subject. And at the time, I tried to look about the different kind of threats that we could have in machine learning. And I didn't find actually a source where I could find this whole list of threats. So I decided to do this research and to look at this subject. And I discovered that actually it's a research area. So that's why we don't have so much content about this subject. But in research, what you have is a lot of really bright people. But what they're doing is like designing attacks in order to attack some machine learning models, and others designing defenses against these attacks. And then it's a cycle, because another guy is going to come and is going to design another attack that is going to break this defense. So it's kind of a game, but actually there is nothing that could help me as a data scientist working on a business project with a real customer in order to make my model safer and have a clear idea of what's happening. So that's how the idea of this article came. I did some research and ended up writing this piece.
Well, I love how you went from needing it. First of all, I love the story about now let's put it into production, because I think everyone can relate to that. And that's probably half of the people in the MLOps community are there because they've had that very same experience. And so it's good to hear that you had that and you were a little bit discombobulated with, well, what do I do now? And, oh, maybe I shouldn't have optimized for those things that I optimized for. Or maybe I was like making things a little over-engineered here. So it's really nice that you were able to see that and learn from it. And then the security part, where you realize that there's only, or the majority of what you were reading out there was research, and it applied to research. It didn't really apply to your specific use case and situation where you needed to have tangible things you could do to make your model more secure. So that is just, it's a great way. You're solving this pain point by learning and by going through the different ways of how you can make this model secure on your own. And then you became a quote unquote expert on it. So I love that journey. And maybe we can talk now about some of these reasons why we should even care about keeping our models secure. I imagine that a lot of people out there, especially data scientists, are thinking in the way that you used to think, and they're just trying to create the best model with the best accuracy score and not really thinking about production yet and everything that comes with production. And so maybe there are a few things. I know in the article you talked about, like, what are things we should care about, or why should we care about these different things?
Yeah, when we're talking about machine learning security, first we have to be aware that machine learning systems are actually software pieces. So they're going to be, in terms of security, you're going to have the software security, cyber security part. But in addition to that, you're going to have some specific security threats for your machine learning model. So there is some part that is already solved, or not solved, but you have a lot of resources or already that is available out there about this software part, but not that much about this specific machine learning part. So when we're talking about machine learning models, the kind of threats that we're going to have, it could be about data or the model. So the model actually is something that you build out of data. So as soon as your model is subject to attacks, it's actually the data that is used, which is a threat as well. So the kind of threats that we're going to have is data extraction. So the ability actually to extract some specific data from your model. And we know that this could be really problematic in terms of privacy first and foremost. About privacy, it could be another type of problem affecting the model by actually corrupting it, making it generate false predictions. So this could be used by harmful people, for example, to avoid some filters. For example, let's say on social media there is a fake news detector. So by manipulating your input in some way, you're going to avoid that filter. And there is also the problem of model stealing. Actually, just by providing an API so that somebody can query your model and get a response, by doing that, a lot of times we're able actually to make a copy of this model. And this is a problem, for example, if actually your service is a paid service, because some people can copy your model and make it free, or use it without you, or it could be a competitor that could steal your model as well. So there are different kind of threats related to models and data, and each kind of threat is going to have some sensitivity. And I think that, of course, not all the projects that we work on every day are maybe sensitive models, but it's something that we should do for each project. It's to think about it and maybe assess the risks of these models.
Yeah, that makes a ton of sense, Sahbi. And so this framework that you've provided for security and the different threats that exist, it's something that sounds very similar to what we discussed with Diego Oppenheimer, the CEO of Algorithmia, who joined us to talk a lot about what MLSecOps looks like with their platform and how they've been thinking about this challenge. How do you, as a data scientist now that you know some of these challenges and some of these threats that are posed to machine learning systems, how have you changed your development practices to mitigate those threats during the course of model development and productionization?
Yeah. So when we talk about security, so we talked about assessing the risk of our models. So I think that each one in the organization can have his role in avoiding these problems. So me as a data scientist, I have to be aware when I build my model if there are security threats associated with it. So if I'm going to fetch data from unreliable sources, this is a security threat. If I'm going to fetch a model from a model zoo, there are different model zoos where people can go to use some pre-trained model. I have to make sure that it's a reliable source as well, because if this model is corrupted, my model is going to be corrupted as well. So there is during modeling, in function of how I am going to use the data and to expose my model, as a data scientist, I should know where are the threats. And then you're going to work with a machine learning engineer, with your manager, and at each stage there could be some responsibility. So here there is an unanswered question. It's the accountability. Who is accountable for that? But for example, as a product owner, I should be able to evaluate the different risks associated with this model. So working with data scientists, we know where are the risks, and we can associate maybe some importance to these risks. And then, as a manager and decision maker, I could decide if I put this model in production as is, or if I do some tweaks to it. That often come actually at the cost of accuracy or other things that I have to tweak.
Got it. So it sounds very logical, which is, as a professional, it's incumbent upon you to really understand some of the day-to-day threats that may emerge. Everybody has to play a role in that, and then to also work as part of a larger team to really take security in as a what's the term? I'm forgetting the term, but almost as like a first consideration, to make that as part of your development practices, and that makes a lot of sense. One of the things I really enjoyed about your article that I would love for us to cover are some of the ways that we can actually secure models on a more almost tactical level. You mentioned things like differential privacy and homomorphic encryption. Could you talk to us a little bit about what some of those, obviously, I would love to, I'd love to, as a data scientist, be completely responsible with all of my security practices and as you said, model zoo or looking at other external sources and take that into account. But assuming I've done all of that, what are the other tools in the toolbox that you covered in the article? And could you give us an introduction to those?
Yes. So
wow,
luckily
that's
for
crazy.
us, for each one of the threats that we mentioned, we have some defenses that exists for this kind of threats. So yeah, when we talk, for example, about the data extraction problem, the fact that for large models we're able to extract data. This could affect very large language models, for example. This kind of models are very subject to this kind of threat. For example, you take there is the algorithms used, for example, in Gmail, the Smart Composer. Some researchers have shown that by prompting the model with the right words, we're able actually to extract very specific data from personal data. So they were able to extract name, phone number, email address, physical address of a real person from this kind of models. So luckily for us, these engineers, they also work at Google. So Google is doing the right things in order to secure this kind of models. But the risk is there, and in order to avoid this problem in large models, we have to understand what the problem. Why are we able to extract this data? It's because actually the model is so complex that it's able to memorize some specific details in the data. So what we can do in order to have a defense against that is one technique that is called differential privacy, is to put a constraint on the model in some way in order actually to control how much it's going to memorize data. So then for us, we're going to have some knob called the epsilon, and depending on where I put the knob, I'm able to decide whether I care about privacy first or accuracy first. So it's going to be a choice in order to choose where I'm going to put this. So this is differential privacy. But
Do you
then,
have? Oh, sorry. Before we jump to the next one, do you have any other stories or occurrences like this Google one where data was leaked in that fashion? Do you have any other ones?
An example is much recent.
No way.
More recent is Microsoft, who recently released Copilot for GitHub. So it's enable you as a developer to have smart suggestion when you're coding. So first thing some people did is just write API key equals and see what the model outputs. And there you're going to have, of course, some privacy and security problem, because it can output some real keys. Sometimes it outputs also some headers of websites with names inside it. But the thing is, Copilot is trained on public data. It's all open source, but you also have some personal details and sensitive data in public data. So it's the problem that we mentioned exists also in GPT-2, the model developed by OpenAI. So in this kind of models, you're going to have this kind of threats. Yeah. But there are other defenses. So for each type of model, you're going to have some defense. One of the most known threats is adversarial examples. The fact by tweaking some inputs, for example, it could be images or text, you're going to make the model output another prediction. So we talked about the spam. It could be in spam filters or in fake news detectors. In social media, you also have some harmful content filters, and if your model is not secured, actually it's possible to design some inputs that it's going to get through these filters. And the problem here is that the only defense is actually to do it before the attacker, to know which kind of transformation he's going to do, and actually train your model with the data augmentation in order that your model is so that your model is more robust to this kind of attacks. So yes,
and these things, I'm just wondering, as you're talking about this, are these, because you're in France, and you probably have heard and looked at the new proposed regulation from the EU and how they talk about this robustness. Do you feel like this kind of strategy will help those who now have to all of a sudden take this new regulation into account?
Yes, exactly. So the EU regulation actually, what's good about it is that it puts a framework and it defines also what's a sensitive AI application, because that's what we're talking about. It's really these kind of systems that should be robust, and that we should be sure that they're not threatened by such attacks. And the EU regulation defines sensitive application as something that is harmful psychologically or physically to people. So yeah, assume that we define it as such. For example, if some people are able to put some harmful content on social media, yeah, this is harmful, and then it shouldn't happen, or you're going to have some fines, etc. When we're talking about autonomous vehicle, yeah, it could be physically harmful. So it's a sensitive system as well. So I think it allows to better to define this kind of sensitive applications as well.
So there's something else that I wanted to talk about that you mentioned, and it is the dangers of federated learning. And I know that federated learning is quite popular these days in the community. So maybe we can go down that route and why that's different than just the normal machine learning.
Yep. Yes. So federated learning is, for just very quick introduction, is about, let's say, distributed learning. So it's the ability to use the data that is going to be in different locations and use it in order to train one model based on all these data, without aggregating all the data in the same location. So it's used, for example, in a smartphone. We take Android or iPhones. There is some federated learning that is used. So in theory, if I'm a hacker and I have a smartphone, actually I'm able to put anything I want in this device. I have total control of the data here on this device, and this data is going to be used in order to learn a model. So this is actually a threat for federated learning, because a hacker is able to inject any data he wants for the final model. And it's even more sensitive because federated learning is also used a lot in the medical areas between hospitals, because we have patients' data in different hospitals, and we want to use all of the data in all the hospitals around the world in order to have the best AI in order to detect some disease. But we don't want to put all the data in the same place, and it's difficult to share data between hospitals. So federated learning is a solution. But for medical data, we have to be really hyper secure when we're manipulating this data. But luckily, I think that the brightest people right now are working on these subjects, and that's why we have some really interesting techniques and defenses that were designed for federated learning. we can talk about homomorphic encryption. It's how actually you ensure that you encrypt your data in some way that you ensure that the computation that you do on encrypted data, you're going to deduct the result from it and unencrypt it in order to get the final result. So it's doing computation on encrypted data. There is also other methods such as secure multi-party computation. So there are different defense techniques designed mostly for federated learning, but we have to also to be aware that it's still a research area and it's improving every day. So we don't have yet the perfect framework, but we have different framework with some advantages and some problems as well.
Yeah, no, that's a great answer and really highlights, I think, in federated learning, there's a lot of excitement about federated learning in a lot of different industries, because I think, you know, the challenge is that a lot of people see data as a strategic asset, and unlocking the value of data has been a challenge because of that. And federated learning has been posited as a solution to that. But what you're highlighting is it's not necessarily a panacea when you consider the security challenges that are involved. I think that's a great point.
Nice vocab word there, panacea. I like that. You've been studying word of the day, huh? There we go.
Yeah, it is. No, it's just so after Demetrius just blew up my train of thought, trying to reconstitute it. I think listening to your descriptions of some of the challenges that are inherent to model development, and security challenge inherent to model development, it seems that, you know, there's almost this process of model interrogation, right? Which is, you know, in some ways similar to what we call interpretability, but is a little bit more directed in the sense that, you know, for example, what these Google researchers did to unpack the smart composed models was a very focused exercise that wasn't just dependent on one analysis like interpretability, which, you know, interpretability, I think people are using SHAP scores or LIME and very, you know, specific techniques. In interrogation, there's almost, you know, an entire process. And to me, I think when I hear you go through it, it seems like there are almost three legs to the stool of model interrogation, right? You have your operational component, where there are different teams, security, ML engineering, data science that can help with it. There's a regulatory piece, right? Which is the regulators themselves are saying, have you answered these questions? And the third stool, or third leg to the stool that I feel like I haven't had a good grasp on is the tooling around this, right? Which is, what are the tools that allow us to interrogate models and to answer some of the security practice challenges that we face, that we just talked about? Where do you think the current status of tooling is, and are there any tools that you found useful in terms of ensuring model security?
Yes, and what's exciting about this is that if you have asked this question when I wrote the article, I think there were none. But a few months later, there are some tools that have emerged, and actually we're starting to see something really interesting in some of the biggest companies, where you have this kind of sensitive systems. These companies are now building some teams that they call AI red teams. So actually, these teams, it's coming from the security area or gaming as well. So you have the red team and the blue team. The blue team is focusing on defensive strategies, and red teams are focused on trying to attack their own systems in order to be aware of the risks and to defend better at the end. And so you have some AI red teams in some big companies like Microsoft, for example, and Facebook. And these teams just started to develop some tools that they are open sourcing right now. For example, we have the Facebook team that developed Ugly. So this is actually a tool that allows to be more robust to adversarial attacks. So it's a tool where they try to try a lot of augmentations on the input data in order to make the model more robust to this kind of attacks. You have Microsoft, who developed a tool called Counterfeit, which looks interesting because the idea is to evaluate the threats of your model. So it's based on this matrix of threats that we just discussed, and it tries to look at these different threats in order to evaluate the risk of the model. So these kind of tools we didn't have some months ago, but it's the tools that we need in order to make our model more secure. And if we look at it, it's actually it's like the same story again, because we had the data scientists, and then with more tools we switched to machine learning engineering in order to be more production focused. And for security, it's the same thing that's happening, because it's a research area, but as soon as we have tools that are developed, we're going to have maybe more profiles who are able to take this and to work on the security of this kind of models.
That's awesome. It's really, really promising to hear that there are so many of these tools that are coming out now. Especially, I think a lot of the ways that, if you look at the history of sort of MLOps to date so far, it's been, you had ML happening in the uniquely talented enterprises like Google, Uber, Pinterest, etc. Then people who built those systems came out and started MLOps tooling companies, right? And then that has enabled it for all other companies to be able to adopt the same best practices that other companies develop more easily. And it sounds like what you're saying is a similar sort of thing is occurring in ML security, where the leading enterprises are developing some new best practices. Those professionals hopefully will come out, start companies, or create knowledge that others then will be able to access to be able to implement ML security best practices. Does that sound like a fair summary?
Yeah, I think it's exactly that, and that's how science works, and that's why we have research. And I think that this domain is really exciting, because at the end it's the fusion of two great domains, which is AI and cybersecurity. Yeah, when you look at the research paper and the problems, it's sometimes you really have to dig into the inner functioning of the model, into the mathematical implication, in order to design some tools like that. And okay.
Yeah, it's very interesting to see. Yeah, I think you highlighted it because you highlighted it exactly right, which is it's not just that there is this research happening in the ML world, security for ML. That's cybersecurity itself is a vast field, and it feels like there's so much, with the advances in cryptography and with the advances, just in terms of thinking about threat points for different cybersecurity systems, and in fact using machine learning for cybersecurity. It's crazy to think about all the different innovative fields. It's all of these different intersections that are happening.
That's true. So we've been hearing about machine learning for cybersecurity, but the cybersecurity of machine learning is actually completely different, and it's a subject on its own as well.
So I wanted to just mention something that was posted in the security and privacy channel on Slack from Diego, actually, who we also spoke to about this a few weeks ago. And when we talked to him, he mentioned how vulnerable or how bad of a practice it is to just go and download anything off of PyPy and bring it onto your Jupyter notebook and then just, import whatever from this on PyPy, and how this article that he shared talks about how Python developers are being targeted with malicious packages on PyPy. And so that's just something that since we are talking about this and the greater ecosystem and ways that you can potentially be vulnerable, I wanted to mention that. Anyone who wants to dig into it more, we can link to that article in the description or you can go into the security and privacy channel. But so my next question for you, Sahbi, is more along the lines of synthetic data. And I've heard a bit about synthetic data, and I'm wondering where you stand on it. Maybe you can just give us your 2 cents and how you feel this can be helpful, or is it not really that important? What would it be used for? Is it a tool that we can use as data scientists to help us create more robust systems?
Yeah, so synthetic data, so for me, it's mainly what you generate using generative models. So it could be images. For example, we see a lot of use cases, or to make some art, like making some paintings that resemble some painter. It's also used in music now. We have some generation of music, but when we talk about security, for me it's not directly synthetic data, but data augmentation. The difference is that what you're going to take is actually your inputs and try to do a lot of transformation on these inputs. So you're going to synthesize example, but you're augmenting some existing data in order to make it more robust to attacks. So by flipping it, if it's images, rotating it. For text, you're going to introduce some, for example, characters, some different words that could be used. So it's more data augmentation. But yeah, I'm trying to think if data synthesis could be used as well, but right now I don't have examples of it.
Yeah, so that makes sense on the synthetic data standpoint. I think just to kind of bring this whole conversation full circle, we've talked about so many different new privacy methods, so to speak, or new sort of security defense tactics, so many potential threats for data scientists to take into account as they develop models. As you sit here in 2021, how do you think, what is your prescription on where do you think, this whole question of ML security will be in 5-10 years? I'm kind of curious how you see things looking like going forward. Will we have, almost automated security practices the same way that we have in other sort of like infrastructure as code, or do you think that, there's a different way that this will develop?
Yeah. I think that actually when you look at the big companies that actually reflect where most of the companies are going when they're going to mature. Today, by creating this kind of AI red teams, the idea actually is even broader than just the model security, because there are so much things at stake. You have the privacy, the security, but also the bias of the algorithms. So all of these things, you have to ensure that your models are always secure and robust to this kind of threats. especially with MLOps and automating how our models are put into production. Tomorrow, I have a robust algorithm that is in place, but that is scrapping some kind of commands from a website. One day or another, a competitor or a malicious person is going to inject some data out there, and I have to be aware that if this happens, what's the implication for my company? So I think that we're going to see more and more of these teams in other companies. So some teams who are really focused on this machine learning security parts. For the moment, I think it's quite some scientific skills that are needed most, because it's still a research area. But as we have seen with data science, with more and more tools that we're going to see, I hope, that are going to be developed, we would have maybe some more software-oriented personas and skills that could also take on this kind of subjects.
So I love that you're talking about this, because when you look at different companies that are heavily relying upon machine learning for their bottom line, and you need to know the implications of what it means to have data poisoning or these different threats that are coming at you, you need to have that very clear, because that could be a heavy hit to your company and the bottom line, like we're talking about. The last thing I want to ask you, which is a bit of a tangent, but I would love to go down this little rabbit hole with you. As you were writing this and as you were trying to figure out what are some ways that my models are vulnerable, what are some threats to them, how can I fix these threats, where did you encounter the biggest pain points? What were some parts where maybe it was in implementing some of these security measures, you realized it was very difficult, or maybe it was just in finding the information on how the model is a threat and then having to try and lock down your model in that way? What were the pain points that you encountered?
Yeah, so thing is, when I wrote the article, it's the content about security was not that available. I think that this is we're seeing more and more content out there. I think luckily for us. So I think one of the biggest hurdles is maybe the level of science that you need in order to understand the attacks and the defenses, because it's really linked to how the model and the learning is done. So it's, I think, yeah, for now you need to have this kind of level of understanding of your models in order to understand how these work. So maybe this could be as well an obstacle for hackers, because in order to design some new methods, maybe there are easier ways to attack some machine learning system than to design a whole new way to corrupt a gradient descent. So it's a good news from one point of view. But what I also liked when I started to make research with especially these new tools that are coming. You have now there is a tool that was released by NVIDIA, I think, which is an environment that would allow anyone to actually try to hack a machine learning model. So it's an environment made for attacks in order to have some hands-on experience and try to understand how it's working. So this is, I think, a good area, and it's good that we start to see this kind of tools. There is another thing that is now organized, I think, by Microsoft. It's actually a challenge. It's like a Kaggle challenge. It's for data science, but here it's not about making the best performance. It's about attacking an existing model, trying to divert it and to make some adversarial attacks against this model, and also in defense, trying to best defend some model and making it robust to these attacks. So I hope that we're going to see more and more initiatives like this, because it's with such initiatives that we're going to have more and more people aware and knowledgeable about how this works.
Yeah, and that's one of the reasons why I love talking to people about security at this point in time, because it feels like it is one of those pieces of machine learning that is a little bit put off to the side, or like you talked about at the beginning, who owns this problem? Who is the one that is responsible for the security piece? And I really like what you said at the beginning on each person has to do their job, whatever that may be. And you really need to look at trying to make your piece of the puzzle as secure as possible. And then once it's handed off, the next person is also trying to make their piece as secure as possible so that you don't have any problems in the future and you don't have these hacks. So with that being said, this has been an excellent conversation. I really, really appreciate talking with you, Sahbi. It has been a long time coming. I know we wanted to do this months ago and we finally got it done. Hopefully everyone enjoyed it. If you are out there still listening, the way that you can show your support is by giving us a like or commenting or subscribing or whatever the cool kids do these days for the podcast and YouTube videos. That's all we got for today. Thank you, everyone. Thank you, Sahbi. Thank you, Vishnu. And the word of the day is, what was it? Panacea? Panacea?
Panacea.
There we go. Hopefully you all learned something.